So I'm Gaetan Castline, Group Manager in the Product Marketing team at VMware. So this is session EA8660, and we're going to be focusing on virtualizing Tier 1 apps. So just want to make sure that I set the focus correctly. So this is going to be about virtualizing existing applications. This is not going to be about vFabric or some of the new Spring Source and Gemstone and other product acquisitions we've done recently. This is really going to be about looking at the most common applications, Exchange, SQL, SAP, and other high-profile applications, and what it means really to virtualize those applications. So in terms of content, we'll start with a brief introduction, then we'll take a look at the most common objections that people usually have, specifically performance and ISV support. We'll then move on to really what are the benefits from an application standpoint. So what does it mean for your application teams to virtualize these applications? And then finally, I'll point you to some of the resources we have to help you actually virtualize these applications. So the starting point for us is that the traditional VMware users, so the VI admins, the IT directors, the CIOs, really want to virtualize typically as much as possible. So very common for us to get into situations where our customers ideally would like to be 100% virtualized. And in many cases, we actually see customers that put in place a virtualization first policy. Now, unfortunately, we have these application owners, right? And these application guys typically don't understand virtualization nearly as much as we do. And they're somewhat skeptical, and probably rightfully so. By the way, any application owners in the room here? Any DBAs, Exchange admins? All right, just a few. And so typically the issues that these teams have are on the one hand related to performance. So how's the application going to perform if I virtualize it? Is it going to be okay? Hey, if it's a big application, very IO intensive, is it going to meet my performance requirements once I virtualize it? The second biggest concern tends to be related to ISV support. So if I virtualize this application, is my ISV going to provide me with the same support as I was getting on physical? And then the last point here is, and this is I think a critical point, is what's in it for the application? So you're asking me to virtualize, and I understand that virtualization is good from an operational standpoint, right? For my infrastructure, it's going to help me reduce costs and better manage infrastructure. But is my application actually going to get anything, going to gain anything by being virtualized? If I'm the application owner, you're asking me to go through a significant amount of change. I want to see something in return, right? And so typically what we see is that the biggest issue to virtualizing Tier 1 apps isn't so much technical. It really is more of an organizational issue and being able to reach out to these application teams. It's also interesting, we've seen many different tactics being used by our customers to actually get these applications virtualized. Some VI owners actually, some VI admins don't even tell their application teams. They just go ahead and virtualize Exchange, virtualize databases, and they don't tell anybody, things run fine, nobody's complaining. That's one way of looking at it. But typically what we see being most successful and probably a better approach is actually to get a closer relationship with these application folks and talk through the issues with them. They're not unreasonable. Typically once you show them the data, once you show them it can be done, they typically open up. So a lot of what you're going to see in this presentation is also some proof points and materials that can really help having that discussion with the application teams. We also think that virtualizing Tier 1 applications is absolutely a critical step on the virtualization journey. So if you look at this, we've probably heard about the journey 1,000 times by now, but there's basically 3 steps, right? The first step is basic consolidation. I'm taking my low-hanging fruit, my easy applications, and I'm virtualizing those. And purely for cost cutting, for consolidation. Second step is what we call the business production phase. This is when you start looking at virtualizing big Tier 1 apps. And you virtualize them not just for cost cutting, but you also virtualize them to get better availability, or simpler availability in some cases, to get better service levels, and that ability to provision applications very, very quickly. The last step is really about the cloud. That's what we call IT as a service. But so that second step here is really a critical step on that journey, and we found that many of our customers actually get stuck at the end of phase one. And going from phase one to phase two is one of the most difficult transitions in that journey, and it does require going after tier one applications. If you don't virtualize tier one applications, you're going to stay stuck at the end of that phase one. And that's why we're really focusing on this at VMware, helping customers virtualize those apps. So I mentioned some of the unique challenges. And I know that many people still think that there's not much Exchange or much SQL being virtualized out there. What I want to show you here is some data points on which applications customers are actually virtualizing. And it is happening. We're actually surprised by how fast it's happening. If you look at Exchange, for example, 38% of Exchange instances in the VMware customer base have been virtualized. 43% of SQL instances have been virtualized. Oracle, for example, 25% of Oracle databases and middleware have been virtualized as well. So those numbers are pretty significant. Ideally, of course, we'd love to get to 100%, but it's going up very, very quickly. Now, what's made this possible? It's interesting. 2 years ago, we gave the same session, and I think we had like 20 people in the room. This year, it's the second time we gave this session. First time was a full room, and this time it's pretty full as well. So it kind of goes to show how much interest we're seeing in our customer base in virtualizing these apps. So why is it happening now? I think two things, right? On the one hand, we've removed the biggest issue we had in the past, and that was related to performance. So today, with a virtual machine that scales to 8 vCPUs, 255 gigs of memory, with an overhead that's limited to between 2% to 10%, we've really basically removed performance objections for 95% of apps. We've measured this across hundreds of thousands of systems, and more than 95% of the applications we've measured would fit easily within that performance envelope. We also have a lot of benchmarks. Now, understand that benchmarks are not always a good representation of what you're running in your data centers, but they do show basic capabilities, right? And so TPCC, for example, and I'll show you more data on this, but almost 9,000 database transactions per second in one VM on TPCC. SpecWeb 2005. So TPCC is a scale-up kind of application, right? A transaction processing database. So we scale that up in a VM, achieve very good results. When you look at scale-out, typically for scale-out applications, we get better than physical results because you can scale out so efficiently using VMware. SpecWeb, for example, we got better than physical results on SpecWeb. TPCH, which is a data warehousing benchmark, we actually got a world record benchmark with PowerShell by scaling out a data warehousing database. So lots of impressive results here from a performance standpoint. The other big one, of course, is ISV support and licensing. Now, the good news here is that Microsoft, SAP, IBM have come out with a very clear position that they're going to provide the same level of support on VMware as they provide on physical systems. So that kind of puts that concern to rest, at least for those three vendors. Now, the one that we always hear about, that people complain about by far the most, is the Oracle position. Just kind of curious, has anybody had to deal with Oracle support and licensing for VMware and had any issues with that? A few of you, okay. And so, there's kind of two sides to this story, or actually I should say three sides. If you talk to your Oracle account team, Oracle sales reps, they're going to tell you that you can't virtualize on VMware, that it's not licensed, it's not supported, just don't do it, it's really bad. If you look at another side of Oracle Corporation, their executives and their support organization, they've actually come out multiple times with public statements that it is supported. They have a support statement on their website. I'm going to show you that later on in the presentation. So just message here is don't stick only to what your account team is telling you. There is other information out there, and you can actually get the support that you need. From a licensing standpoint, I'm not going to spend too much time on this because it does get complicated very quickly. But we basically see three kinds of licensing models. One is based on a business metric. Take SAP, for example. They're going to license based on number of business users. No impact of virtualization on that side, so that's simple. Then we have a number of vendors that license by virtual CPU. that is typically beneficial to virtualization. So if you're going to use IBM software, for example, they have subcapacity licensing. It's per vCPU licensing. In that case, you can actually reduce your licensing costs with VMware. Another common one is by physical processor, typically applied by Oracle, for example. Some Microsoft software is licensed in this way as well. That's where it gets a little bit more difficult, and I'll go into more details on that. But the issue with that is if you take one VM, put it on a big ESX cluster, some vendors are going to ask that you license all of the physical processors just for that one VM. It can become very cost prohibitive very quickly. There's actually a workaround. If you do consolidation and you put multiple VMs like that on VMware, there's actually a way to use that to your advantage. I'll show more information on that later on in the presentation. So, we've really removed the two most common objections that these application teams always had with virtualization. We've removed the technical objections, but we still have that perception issue that we need to fight, right? So that's why I was saying earlier on in the presentation, we think it's absolutely critical for VI folks, for the owners of ESX, of vSphere, to actually reach out to these application teams, give them the data. We have a lot of good stuff on the website that you can use with these application teams to really get that discussion going. Now, beyond the objections, we also have that question of, hey, what's in it for the application team? And this week, with the introduction of vCloud Director, vSphere, there's never actually been a better time to explain to an application team that vSphere is actually a better platform for his application. Those things that typically fall under three categories. Why is vSphere better for an app? Well, on the one hand, there's of course the cost aspect, right? You're going to pay less to get your application hosted if you're running on vSphere. In some cases, you can also reduce licensing costs. Number two is about application quality of service. So hey, if you put your application on vSphere, now you have access to a lot of cool capabilities that you normally wouldn't have access to. VMware HA, VMware fault tolerance, site recovery manager. Also that ability to scale up and down dynamically. So hey, what if your VM runs out of capacity? With vSphere, you can hot add capacity to that VM and expand it on the fly. So all sorts of neat things that an application team normally doesn't see. And then finally, there's cloud computing. So everybody's talking about cloud computing, but what do you do if you're the SAP guy? Or what do you do if you're the DBA? How do you bring the benefits of cloud computing to your application? There's not that many options out there for you. And vSphere, and now with vCloud Director, is really designed to do that, right? To enable fast provisioning, self-service provisioning for all of your legacy apps. So that's a message that we really expect application teams to be extremely receptive to. All right, so to kind of finish the introduction here, I want to show you some of the recent data points we've seen in the media and from analysts. On the top there, you have an article by Network World. I thought it was interesting. They're recommending to actually virtualize Microsoft Exchange, but not with Hyper-V, which I found kind of a nice little story. And essentially what they said is Hyper-V is missing really your key disaster recovery capabilities to make it a good platform for Exchange. Another data point here, Berlin Group, that basically looked at running email on either bare metal physical systems and did a comparison of that with virtual platforms. And they found that for 6 out of the 7 categories, virtualization was actually better than physical systems. There's a detail of those categories on the bottom there. So they found that virtualization was better for business continuity. That's kind of obvious with encapsulation of everything within a VM and site recovery manager. It's better from a hardware standpoint and an infrastructure standpoint. Kind of all understand that as well, consolidation, easier management. Some of the more interesting ones is they found that virtualization was better from a scalability standpoint. And we've actually released some benchmarks on that in the past, that you can actually scale out Exchange much more efficiently with VMware than you could do on a dedicated physical host. Better for security and better for testing. The support one is the only one where they found virtual to be not as good as physical. Kind of interesting. I mean, we haven't seen issues with customers running Exchange on VMware getting the support they need from Microsoft, but they might also be thinking about other email platforms. But this, I thought, was really good external validation of the benefits of virtualizing email. Another example is Indiana University here that took a number of high-end Oracle databases, moved them from P-Series to x86. There's actually a session on this today at 1:30. It's a great session. We have two speakers, Rob Loudon from Indiana University and Dave Welch from House of Brick, that know the stuff in and out. So if you're interested in virtualizing Oracle, definitely would encourage you to attend that session. But the nice thing about what happened here is they basically looked at the most demanding database. And they figured, hey, if we can virtualize the most demanding one, then we can virtualize all of them, right? And so they chose the database that was supporting the class management application, 125,000 total users, 12,000 concurrent users at peak. Peak being right about now when all the students come back and sign up for classes. And that database was initially running on a P-Series machine and utilizing 9 Power 5 cores at peak, 100% utilization. And they were in a phase where they had to refresh those Power 5 systems, and they were like, well, you know, we have a choice between spending like $700,000 to actually go out and buy new P-Series machines, or we can put them on x86 with Linux. And that was really their objective. They basically cut down the cost of hosting those databases by a factor of 10x by moving them from P-Series to x86. And they virtualized them. That database specifically, they did a lot of testing. They put it on an 8 vCPU VM and brought utilization down from 100% to about 50%. So that kind of also goes to show how powerful x86 has become, right? If you're looking at moving things from Unix to x86, those x86 processors just offer so much more capacity than Unix processors that you'd actually be surprised at how good the results might be once you virtualize. All right, so I'm now going to spend some time digging deeper on the performance side of things. And we all understand at VMware that there's still a strong perception in the marketplace that our customers still think that virtualization is mostly adequate for small apps, right? Non-IO intensive, small, non-business critical applications. And I think that perception goes back to ESX2. So if you look at ESX2, we were in a phase where a VM could only scale to 1 vCPU, 4 gigs of memory, with a lot of overhead, 30 to 60% overhead, and less than 10,000 IOPS supported per VM. Those were pretty significant restrictions. Back then, we had customers that would take a big Exchange database or a big Exchange mailbox or a big SQL database, put it in a VM, have IO limitations, and come complain, hey, it doesn't scale, it can't support my apps. And that was indeed the case back then. But now if you look at ESX4, and now with ESX 4.1, we've taken that a little bit further, but we've made a huge leap in performance capabilities. We've gone from 1 vCPU to 8 vCPUs, 4 gigs to 255 gigs. That first line there, the overhead, we've gone from 30 to 60% overhead down to 2 to 10% overhead on average. And the last line, IOPS, I think that's the most significant change. We've done a 30x jump in disk I/O capabilities. So for those of you that can relate to that IOPS number, 300,000 is really a massive amount of IOPS. When we did this testing at VMware, we actually needed multiple racks of spindles just to drive the I/O coming from one single VM. Most customers will never get anywhere close to 300,000 IOPS. There's also some cool new stuff in vSphere 4.1. I'm not sure if you read the keynote yesterday. We talked about this at the keynote. But one issue we had in the past is how do you actually control who gets access to the I/O, right? So if you had, say, 3 VMs, an Exchange VM, an online web store VM, and then a data mining VM, you want the two on the left to actually have first access to the I/O, right? The real-time processing applications, you don't want to have the users just waiting there to get their access to the I/O. Unfortunately, in some cases, you'd have that data mining application which would kick up a batch job, for example, and suck up all the I/O. So bad situation, right? You're getting the I/O allocated where you don't want it. With vSphere 4.1, you now have network and storage I/O controls. So this works very much like CPU shares and reservations that you had in the past, but you can now do that for network and storage I/O and really limit I/O access to those undesired applications and provide it in priority to your tier 1 apps. Another interesting innovation in vSphere 4.1 is memory compression. So it used to be that if you ran into a situation where you had memory contention, well, your system would start swapping. And of course, once you start swapping, you'll see performance degrade very, very quickly. With vSphere 4.1, we now have a new memory hierarchy that sits between swapping and live memory. We call it memory compression. And in the event of memory contention, we don't actually immediately start swapping. We'll actually first start compressing the memory as much as possible. That's about 1,000 times faster than swapping. So that gives you kind of a bigger comfort zone and ability to allocate and to some extent over-allocate memory, which is good because memory tends to be the #1 bottleneck in consolidation ratios today. Also, high-end benchmark. I mentioned TPCC earlier on in the presentation. What you see here is the result of that TPCC benchmark. So TPCC is a database transaction processing benchmark, probably the most difficult thing you can run in a VM, extremely I/O intensive, probably about 2 to 4 times more I/O intensive than a standard OLTP database. And we ran it natively, then we ran it in a VM scaling from 1 to 8 CPUs. You can see the results there. Some of the things that stand out, almost 9,000 database transactions per second in a single VM. A very good scalability from 1 to 8 vCPUs, 60,000 IOPS coming from that one VM again. About a 15% overhead. Now that's higher than the number I mentioned earlier. I mentioned 2 to 10%. Those are the average numbers. 15% is probably an upper bound. As I mentioned, this is a very difficult application to run in a VM. The I/O intensity actually increases that overhead number. So that 15% you can look at almost as an upper limit on the maximum overhead you're ever going to get. Now, I talked about high-end applications. And when we think about virtualizing our databases, for example, we kind of automatically think about the biggest instance we have, right? Am I going to be able to virtualize that 16 CPU Oracle database? So we also took a look at what the average database needs. Because we kind of saw a lot of those small databases lying around. We're like, well, it seems like most databases don't get anywhere close to needing the capacity of a full VM. And so we measured this, the capacity requirements of Oracle databases, again, based on 700,000 systems we've analyzed in customer production environments. And what we saw is that the average Oracle database only needs 2 to 4 CPUs. Well, it's actually only provisioned with 2 to 4 CPUs, but uses those at 6% on average. Is only provisioned with 4 to 8 gigs of memory, 50% utilized, only 2,000 IOPS. So disk I/O is actually not that high for the average database, and 2 megabits per second. So that average database will fit easily within a VM. So when you look at this, we're not so much pushing you to go out and virtualize that very biggest instance that you have, right? What we're trying to communicate here is that you probably have a lot of smaller instances that will really benefit a lot from being virtualized. And hey, if you have that 32 CPU UNIX database, don't touch that. Leave that on UNIX for now. But there's an opportunity to really go out after all of those smaller tier 2, tier 3 instances. SQL consolidation. This is also interesting because we often get the feedback that, hey, if I'm going to put SQL or Exchange or a database or something I/O intensive on ESX, I'm going to make sure to only put one VM that's super I/O intensive on an ESX host. What I want to show you here is that you don't have to do that. You can perfectly well put multiple I/O intensive applications on a single host. This is a SQL consolidation benchmark. It's one host with 8 physical processor cores, and each VM has 2 vCPUs. So once we've provisioned 4 VMs, we've basically allocated all of the CPU capacity. Once we continue adding VMs, we're over-allocating CPU. And what you can see the gray bar is that the total system throughput kind of goes up almost linearly from 1 to 7 VMs, and the latency, which is the line on top, is not impacted all that much by that stacking. So it can absolutely be done. If you want to consolidate SQL on one host, go ahead and do it. It's safe to do it. You're not going to suffer from I/O problems. Now, I do want to mention that in many cases, when we see performance issues today, because we still see them, it's most of the time not due to ESX. It's really a storage configuration in the back end, right? It's the fact that you haven't allocated enough storage bandwidth to support those consolidated benchmarks. So that's one area that you definitely want to pay attention to, is how you configure your storage in the back end. But the ESX host itself is not going to be a bottleneck. All right, so ISV support and licensing, and I'm going to go through this a little bit faster because we're going to run out of time otherwise. But the one thing I did want to focus on is Oracle support, because I know that's a very, very common issue. We hear customers asking about that all the time. And as I mentioned, many people in the field organization from Oracle are going to tell you it's not supported and you can't virtualize it. If you actually look at some of the other data points, publicly, Oracle executives are always talking about how they support VMware and they're open and they love us, et cetera, et cetera. This is on the left-hand side is some quotes from a financial analyst meeting. And I mean, you can read through it if you want, but essentially you have this analyst asking Larry Ellison if they're going to provide support for their databases and applications running on VMware. And you have Larry Ellison basically saying, yes, we do. We're open and we will provide support for that. On the right-hand side, you actually have the official support statement from Oracle for VMware. So if you call the Oracle support organization, this is what they're going to refer to. There's a note. It's My Oracle Support Note 249.212.1. And what that note says is a couple of things. One is Oracle doesn't certify VMware. Okay, so that's one thing that they come out and say. It's not certified. Now, they don't have a habit of certifying anything below the OS. So we don't feel that VMware should actually be certified by Oracle. There doesn't seem to be a need. They never certify any hardware systems. They never certify a platform that sits below the OS. Beyond that, what it says is that they may accept support requests if they already know about the bugs or if they don't think that the problem is related to VMware, but they reserve the right to require physical reproduction if they think the issue is related to VMware. Now, that last statement is actually very common. You're going to get that in almost all ISV support statements. So it's not specific to Oracle. It's something that is almost never applied. They know that technically it's fine to virtualize those applications, and so they almost never request it. There's a small chance that they might. In that case, you have to do a V2P or some kind of migration of your Oracle to a physical system. It's a matter of a few hours. It's not the end of the world, but you do have to be comfortable with that restriction. And then the last thing is that Oracle RAC is the only thing that is explicitly excluded from that support statement. Okay. From a licensing standpoint, and this goes back to one of the points I was mentioning earlier on in the presentation, if you have an application that's licensed by physical processor, there's potentially an issue. You take one VM that's running that application, you put it on an ESX cluster, that VM is going to vMotion around, is going to potentially sit on any host in that cluster, and a lot of ISVs are going to tell you that you have to license every single one of those physical processors to virtualize just that one VM. Now, if you have a big ESX cluster, you can imagine that can lead to pretty significant costs pretty quickly. So one thing that's new with vSphere 4.1 is DRS host affinity rules. What that allows you to do is really to peg a VM to one or a subset of hosts in your cluster. So in this example, we have 4 VMs that were initially running on 4 dedicated hosts, 32 processor cores licensed. Then you're moving those onto an ESX cluster, but you only want to license the 2 boxes on the right. You don't want to license the entire cluster. So you can make sure that those VMs remain pegged to those 2 licensed hosts and can't vMotion or VMware HA or DRS to any unlicensed hosts. So that helps a lot. Now, again, this is something that you have to talk about with your ISV. We can't, we can't make licensing decisions for ISVs. I know in the case of Oracle, we have customers that have been able to get this accepted by them. We have customers that have not, right? So it's kind of it depends, kind of answer. All right, so now looking at virtualization benefits for applications, right? Why would an app owner actually want to virtualize? And we'll start with efficiency. And what I want to do here is use a database example. So in our customer base, I think the majority of our customers have at some point tried to do some kind of database consolidation without VMware, right? The DBAs went out and had a database consolidation project. The two most common ways of doing that are on the left-hand side, having what we call multi-instancing, so multiple SQL instances on one OS image, or they can do some kind of database stacking where they have just one big database, like SQL instance, and put multiple logical databases on that instance. Those are difficult to do. We have seen customers being successful with that, but it's very difficult to do. You've got to run all of your databases on the same version of SQL. There's no OS isolation. There's sometimes a lack of database isolation. So there's all sorts of caveats with doing this. And in many cases, it's not that efficient because it is so difficult. So what a lot of DBAs are now doing is looking at vSphere specifically as a database consolidation platform. And what they get with vSphere is just a much simpler way to actually do that consolidation. They can, for example, do a P2V. So imagine they have this old database lying around, a database that's been there for like 3 years. Nobody really remembers how it was configured. Nobody wants to mess around with it. Well, with VMware, you can just P2V that. You don't have to reconfigure anything. You just P2V that old database. It sits in a VM, and boom, you're done. You can consolidate it. You can vMotion, things that are obvious to us, but to a DBA that's tried to do conventional database consolidation is something that's very beneficial. Allows them to load balance and get basic level of availability. If you look at the numbers, what you have on the left-hand side is kind of a typical SQL deployment, 8 hosts, each running one SQL instance, each with 2 physical sockets. The cost for that is about $600,000, and most of the cost is on the SQL licensing side. The SQL licenses are not cheap, right? You're paying a lot of money for those. On the right-hand side, we have a customer that creates a dedicated ESX cluster just for SQL, licenses all the physical sockets in that cluster, and then has an all-you-can-eat environment where he can put as many SQL VMs as he wants without buying additional licenses. So total cost in this case goes from $600K to about $160,000. So huge cost savings, and most of that cost savings is not on the infrastructure side, it's really on the SQL licensing side. All right. So now looking at agility, I think the biggest reason, after cost cutting, the biggest reason why application owners want to virtualize is to simplify HA. So if you look at HA today, we actually see a lot of HA silos, right? So Oracle will have, for example, RAC or data guard. You might use database mirroring or Microsoft clustering for SQL. You might have DAG or CCR for Exchange. And then you have your middleware. I mean, you're dealing with a lot of different HA solutions specific to each application. Now, one, if you're willing to pay for all that. 2, if you can get it set up properly, it's probably going to work really well for you. But it is expensive. You need the staff to manage it. In many cases, there's a risk of configuration error where one of these would not come back up in the event of a failure. So these silos are really kind of painful to manage. The VMware value proposition, of course, is kind of the opposite. It's instead of looking at these application-specific silos, is get your availability provided by the infrastructure. And the things that we provide here are for local availability, VMware HA, which is now which can now be made application aware with some of the new products announced this week. VMware fault tolerance, vMotion. For site protection, you have vCenter Site Recovery Manager. And then for data protection, you have VMware Data Recovery and vStorage APIs. The biggest difference between this and what's being done traditionally is that you're now looking at one common availability mechanism for all of your applications instead of splitting it up by application silos. I mentioned HA being application aware. I think this is kind of a big deal for customers virtualizing tier 1 apps. With vSphere 4.1, we actually introduced new APIs that open up VMware HA to third-party vendors. And for example, what Symantec has done is they've taken the application monitoring agents from VCS, from Veritas Cluster Server, and they've made those available for VMware. So what you can do is install those agents in VMs. They're going to monitor the status of your application. If there's an issue with the application inside the VM, they're going to attempt to restart the app within the VM. If that's not successful, they're then going to trigger a VMware HA event. So in the past, if you kind of look at the difference between VMware HA or application level clustering, there were two main differences. Application awareness was one of them, and then failover time was the second one. With this, we've kind of resolved that application awareness issue, right? Now, it is a different product. You do have, this is a Symantec product. It's not a VMware product, but I think it is very compelling for protecting tier 1 apps. Then we have VMware fault tolerance. I'm assuming most of you have heard about fault tolerance in the past, but essentially, FT is a continuous availability option. So it's the answer to that second gap between VMware HA and app level clustering, which was failover time. With FT, you basically get continuous availability. You have two VMs in exact lockstep with each other. If one of them goes down, the other one's going to pick up instantaneously. The user's not going to see anything. There's not going to be any disconnections to a database or a web tier. Everything's just going to fade over transparently and continuously. So if you kind of look at how this gets applied, and I'm using a database example, what we typically see is somewhere around 5% of databases being protected with a continuous availability solution, database mirroring or RAC, for example. 5 to 10% being protected with an automated restart capability. That leaves about 90% of database instances unprotected. Now, these are going to be the tier 2 and tier 3 databases, but still, you ideally would like to have some level of protection for those. And this is where HA is most successful, right? So we're not saying that HA is always going to replace application clustering. That's not the case. There's still a different level of functionality between app-level clustering and HA. But when it's good enough, it's very cost-effective, very simple. You don't need to deal with those app-level clustering options. So first off, VMware HA is used to protect all those otherwise unprotected application instances. We also see some cases where customers actually replace MSCS, for example, with VMware HA because it is so much more cost-effective and simple. And then vMotion for planned downtime and fault tolerance. Fault tolerance does have a restriction I didn't mention. You can only run one vCPU VM with fault tolerance. You can only use it for your small applications. But when you have a small app that needs continuous availability, that's an option. And then also want to talk a little bit about MSCS support. Just out of curiosity, anybody here doing MSCS or would like to do MSCS on VMware? Just a few of you, okay. So I know that there's a little bit of frustration within the VMware user community about our support for MSCS. And I know it's a little bit limited. We're actually working on making that better. But I also want to clarify the position because it is a little bit ambiguous. So first off, all Microsoft application clustering is not based on MSCS, right? So if, for example, if you're doing Microsoft SQL database mirroring, that's not using MSCS. If you're doing Exchange database access groups or CCR to protect Exchange mailboxes, that's not using MSCS. Both of those examples are shared nothing types of clustering, and you can run those on VMware. We're not restricting the use of those clustering options on VMware. Now, if you're using MSCS specifically, there are restrictions. They're being kind of reduced over time. Still not where we'd like it to be, but we're working on it. From a storage protocol standpoint, you can only do MSCS with Fiber Channel on VMware today. We do not support iSCSI, NFS, or Fiber Channel over Ethernet. You can only do it with RDMs. You cannot do MSCS with VMFS. Today, in the past, we only supported 2-node MSCS clusters. With ESX 4.0, you can now do more than 2 nodes. You can now vMotion and do DRS or fault tolerance with an MSCS protected VM. And then finally, from a VMware HA standpoint, and this is new with ESX 4.1, you're now allowed to run VMware HA in conjunction with MSCS, right? So we're kind of lifting some of those restrictions over time. And the restrictions in many cases are not so much technical as just a QA issue from our standpoint. Right? We haven't certified these configurations, so our support organization is not comfortable actually supporting them. From a technical standpoint, we know that iSCSI, for example, works absolutely fine. We have many customers doing iSCSI MSCS clusters on VMware, that's fine, but you have to be comfortable with the fact that VMware is not officially supporting that. VMFS, fine as well, you don't have to do RDMs. The other ones, vMotion, DRS, and FT, are a little bit more complicated. There's actually an underlying technical issue there with shared SCSI buses. So that's something that, again, you can do. It's going to work fine 99.99% of the time. There's a small chance that something in that shared SCSI bus might get a technical glitch with a vMotion or an FT event. Okay. And then finally, on the availability side, we found that Site Recovery Manager is actually a huge draw for a lot of these applications. Once you're running on VMware, you can protect those apps with Site Recovery Manager, a very convenient way also of providing this common DR mechanism across all of your apps. And then, of course, this week we've announced vShield, which basically includes a load balancer, firewall, edge access, VPN into one single virtual appliance that really allows you to make virtual more secure than physical. All right. Another big thing that VMware can help with is what I call the finger pointing game. Right? So imagine that you have an end user calling you up and saying, hey, my application's slow, I'm not sure what's going on. Most of the time, we actually see this turn into a finger pointing game, right? So the app guys are going to point to the infrastructure guys, and then within infrastructure, it's going to be between the networking guys or the storage guys or the server guys. Nobody really knows what's going on. While that's being figured out, the poor end user is actually still waiting for his issue to be resolved. So a couple of things that VMware can help with in that regard. One is Capacity IQ. So Capacity IQ is designed to be an infrastructure capacity management solution, right? So it's going to tell you when you're going to run out of CPU capacity, when you're going to run out of network capacity or storage capacity. But it's also used to right-size VMs. So capacity planning is always painful. When you deploy a new app, how much CPU do I give it? How much memory do I give it? Nobody really knows, and that's how most people actually end up over-provisioning by a factor of 5x or so. With Capacity IQ, you can be a little bit sloppy with your capacity planning initially. Just give the VM full vCPUs even if you think it only needs 2. Watch Capacity IQ. Capacity IQ is going to do trending over time. It's going to tell you if you've over-provisioned the VM. And if so, you can resize that VM based on recommendations from Capacity IQ. You can also increase the size if you've under-provisioned the VM. And then we have AppSpeed. And I think AppSpeed is kind of a unique product because it's one of the only products that actually has access to all of the switches, all of the transactions going through all the switches. It's actually listening to the virtual switches on ESX hosts. So it has kind of this unique viewpoint. And what it does is based on all the transactions going through the VMs, first off, it's building a map. It's telling you these are like the 10 business services we've identified, and this is how they flow through your different VMs. Next thing it does is it watches quality of service from a business service standpoint. So it's going to tell you this is the latency, the error rate, and availability that you're getting for your business services. When there's an SLA violation, it can immediately tell you which VM is responsible for that SLA violation. So look at Capacity IQ kind of as the longer-term planning tool and AppSpeed as the real-time performance monitoring tool. And then in this case, imagine you've noticed that your SQL backend is running out of capacity. Well, the beauty of vSphere is how easy it is to adjust capacity. So say that VM had 1 vCPU and 2 gigs of memory. well, you can make that VM go from 1 vCPU to 4 vCPUs, 2 gigs to 8 gigs on the fly. You don't even need to restart the VM now. We call that hot add of capacity. You do need an OS and an application that support hot add. So the latest Windows versions do support that. SQL now supports that as well. When they do, you're going to see those applications self-adjust for that additional capacity, and you're going to see them being able to handle a higher transactional load while bringing latency back to where it should be. And then now very briefly, just a few slides, I also want to talk about some of the cloud aspects and what it means for app teams. So if you're a developer, and say you have a new development project, in the past you had a choice between basically begging IT operations to have your new development environment provisioned, right? Hey, I need a LAMP stack. IT, can you please give me that as fast as possible because I need to get going with my development project. The second option was to go to Amazon and to self-service, self-provision VMs and start developing on those. Now, that was much faster, it's self-service, so it's much more convenient, but the issue is how do I bring those applications back afterwards, right? So I've developed on Amazon, am I going to be able to bring those applications back to my internal infrastructure? So you kind of had a trade-off. Now, vCloud Director, which we just announced this week, is really designed to eliminate that trade-off. Give the users the same kind of self-service access and the same speed that they'd get on Amazon, but using your own internal infrastructure, right? And so the idea is give developers, give application teams, first off, a standard catalog of services. So if I have a new LAMP application, a LAMP stack I need for development, I can just go out and check out a pre-configured LAMP stack. I self-provision that, I have access to it immediately, and then I'm basically billed based on my usage, right? Hey, you've had those VMs up for like 2 weeks. Well, this is how much it costs you. So that I think is going to be one of the most powerful benefits from an application team standpoint. And then we have vApps. And vApps were new with vSphere 4.0. And the vApp is really intended to kind of streamline the handoff between dev teams or ISVs and IT operations. So in the past, application teams would just give you application binaries. You'd have to install the OS, install the application, connect the applications to each other, so kind of a lengthy and error-prone process. With the vApp, your developers or your ISV can hand you this neat package, a pre-deployed application. It can be a multi-tier application. So for example, you can have 3 VMs, web, app, and database VM, pre-installed with the OS, pre-configured. There's network fencing within the vApp, so you don't have to connect those together. And then you can also, for example, specify the boot sequence. Hey, the database has to come up first, then the app tier, then the web tier. So from an operation standpoint, all you need to do is take this neat package, put it on vSphere, set the external network configurations, and you're done. Right? So very simple, much simpler than actually manually installing each of those app tiers and connecting them. So that's it. Just want to point you to some resources. So we've actually invested a lot of time and effort at VMware to come up with best practices, reference architectures, sizing guides, HA recommendations, technical papers on the key tier 1 applications. So specifically, we've put a lot of effort into Exchange, SQL, SharePoint, Oracle, and SAP. If you're interested, I'd encourage you to actually look at the solutions section of VMware.com, and there's pages dedicated to those apps with all of those best practices and recommendations. Another good place to check is the VMTN user communities. So there's a very active user community on email, for example. You can check those out on VMTN and get information and ask questions directly from the users. So with that, I think we have about 10 minutes left for questions, so I'm happy to take any questions you might have. Yeah, question in the back? I'm sorry, I have a tough time understanding you.
How many applications does AppSpeed understand currently, and what's the roadmap for additional ones?
Okay, so AppSpeed does great with like your standard web apps, right? Like 3-tier applications. So any middleware, for example, Java middleware, most of the common databases, web servers, all of those it understands very well. Where we run into some issues is sometimes with proprietary applications, where we don't always have the right levels of security to actually look into the transactions. So the actual roadmap, I don't know, but I do know that for most of your common, especially custom applications, web apps, it's going to do great. What you want to really pay attention to is when you have a software vendor-based application.
What about Citrix?
Does it support it? I don't know. You'd have to look at the product pages. I'm not sure about that one specifically. Any other questions? Yep, question?
On the VApps, you described how developers building applications sometimes use VApps and communicate package lines that integrations and relationships with the web app databases or whatever.
Yeah.
What is the developer? Is it the VApp product or interface the developer uses to define that?
So actually, if you have vSphere 4.0, you have access to VApps. So you can yourself basically set up a VApp, specify which VMs go into that VApp. Now we also have VMware Studio, which is basically meant to be used by developers to actually build VApps. And the idea is that if you look at vCloud Director, for example, you have self-service access, but the service itself, like the service catalog, will actually be a collection of VApps. And what you're putting into a deployment is actually a VApp. So instead of having, for example, if you want a LAMP stack, instead of having to go and pick and choose your own MySQL VM and whatever you need for that development environment, self-deploying each individual VM and connecting them, you just take that VApp and deploy that. And vStudio is basically what a developer will use to actually build VApps.
Are there any APIs, whatever, that VApps can expose? Or something that third-party interfaces might want to see this topology?
No, not today. Now, the idea over time is that you'd attach a number of policies with the VApp, right? So say, hey, this is the level of availability that this VApp needs. This is the number of vCPUs that this VApp needs. And so the idea is that if you're an ISV, you can actually go and attach policies to that VApp so that when you deploy it onto vSphere, not only is it ready to go, but you also don't have to go and manually adjust all the settings for that VApp, right? All right, any other question? Yep.
In 4.1,
Right.
is that something that's built into 4.1, or is there something additional that I need to buy?
So question about AppAware HA. So AppAware HA, so first thing is VMware itself doesn't bring application awareness, right? So what we've done in 4.1 is we've introduced APIs. There's basically now a heartbeat mechanism between VMware HA and the VM. But the application monitoring itself isn't done by VMware. In this case, we have two vendors that we know of that have products, Symantec Application HA, which was just introduced, I think this week, announced last week. I think it's going to be GA by the end of this month. And so that product basically does the monitoring inside the VM, then communicates through the heartbeat when an HA event needs to get triggered. There's another product from Neverfail. I'm not sure what the status is of that one, but those are the two that we know of. I'm anticipating there's going to be more over time, but you do need to have that third-party product to actually leverage the APIs that we expose. Any other questions? Yep.
You said AppSpeed works with the internal switches with VMware. Does that support the Nexus 1000V as well?
I'm sorry, guys.
You said AppSpeed can look at the traffic on the V switches.
Yeah.
Does that support the Nexus 1000V as well?
Oh, so does AppSpeed support the Nexus? I believe it does. I am not 100% sure. So yeah, so if you're interested, there's actually app speed in the booth with people that can probably answer that question. I think it does, but not 100% sure.
Okay, thank you.
What was that? It does. Oh. Okay, thanks. Any other questions? No? All right, thanks.